Welcome back, Gangies. We're back once again. The darkness pervades every living corner and breathing essence of the planet and will eventually suck us all into the nothingness. That being the case, we decide to forge on anyway and LeetCode. So, feel strong, man. So here, this is where we're at. I'm loading up the links as we speak, and it remains to be known, and it remains to be seen whether or not sitting is the optimal position for the human man or the human person. So I'm now of the mindset, honestly, I could never stand people who sit in the first place. So now that I'm laying, I realize that now this is the superior system. So forget any delineations based on class, religion, or race. It's going to be based on sitting method. So that's kind of where we're at. And yeah, we've been going through Discord, checking everyone to make certain whether or not their LeetCode position is up to par. And if so, we've been promoting them to management positions. Those who have not been, however, they have been demoted. So that's kind of where we're at. But fortunately, before we begin, we do have some comments to take a look at. So let me load this baby up real quick. If we take a look here, we can see we have an awesome comment from an awesome human here, Gabe Guio. Cool name, even cooler profile picture. He says, I bought a standing desk so I can lay on it and do LeetCode. Need I say more? Need we say more? Need we say more? So Gabe is one of the people we recently promoted in Discord to receive a title of honorary coding chamber aficionado. So in the event that we should pass, the baton will be passed to him as well as all of my assets and my next of kin. So shout out to Gabe. This is how we're going to be changing things going forward. So we're looking for some innovation to be had, and this is it. So this is so funny to me. I don't know, for some reason, now that we're laying in bed, we've come full circle here. So this is the cost. So this is where we're at. And then we have legendary coffee ninja, entrepreneur, part-time author, serial unicorn startup creator himself. Also part-time Anbu ninja, as well as professional computer toucher. The thumbnail made me click, I'm not gonna lie. A necessary evil. A necessary evil, man. So, yeah, we're doing LeetCode, but we're going to be releasing a paper on the benefits of doing LeetCode in a supine position, particularly at the torso angle at around 45 degrees, and the lower part of the body angled at approximately 30 degrees. This is ideal LeetCoding position, so as to suck the gravitational pull that the blood would typically be working towards getting to our important arteries and cells. It's now going to be rushing towards our torso, helping us to process our food faster, and thus increasing the output of our brain power. So I'm thinking that could be the wave, but other than that, yeah, I'm just super tired. I've been having some trouble sleeping recently. And this is where we're at, so a necessary evil. Hopefully we can get some good sleep tonight. But with so many things to be done, who knows? So that being the case, fortunately we're in the Coliseum, and what better way to spend our time than to see if we have what it takes. So we've been making some good progress on the LeetCode problems. I think we did rotating this matrix problem yesterday, which I actually can't believe that we were able to solve. So that's a feel strong, man. Then we did the check if it's a straight line. I think the way we solved this was that I was going to do something crazy and use the slope formula to calculate all the possible points that a point could have, but only using natural numbers. I think this is going to be crazy. So instead what we did was we want to make sure that all the numbers lie on the same line. All the points lie on the same line. To do that, what we did was we calculated the slope for all points. Right, we need 2 points to calculate the slope. So we made sure that there was a straight line going to the first two, and then a straight line going from 2 through to 3, 4, 3, 4 to 4, 5, and 4, 5 to 5, 6. But first we sorted, and I wonder if there was even a need to sort. I don't even think you need to sort. Oh, you do! Oh, wait, no, you don't. Maybe you don't. Wait a second, we never finished this. Wait, yeah, so this is what we're gonna do today. It seems like we don't actually need to sort this anyway. So we're gonna try and figure that out, and I think we're just actually gonna jump into it. So we have a 30-minute, classic 30-minute session to be had. I wonder if my neck is being damaged by this. It's unclear. So we're gonna implement. This is where we're at. So this is where we're at. So why wasn't this working? We're given an array of coordinates. Coordinates y is equal to x y. We want to make sure that all the points lie on the same line. To do that, we use this formula to calculate the slope between 2 points. Unfortunately, though, it doesn't seem to work when we have a point with 0, 0. Now, I'm wondering why that is. We have some console. We have some output in the console. So we're putting m and b. We're calculating m to be infinity. It's unclear why that is, and b to be non. So if we just take the coordinates, right, and just print coordinates of 0 as well as coordinates of 1, you can see what we're working with and see why that's an issue. Then I'm going to copy this test case. And hopefully we can make sense of this. So it looks like we have 0, 0, and 0, 1. So when we do y2, which is 0, 0 minus 1 gives you -1. Then we have x2, which is 0 minus 0, and then we end up dividing by 0. And we can't divide by 0 because that's crazy. Well, safely enough, though, I feel like we can safely ignore. I feel like we can safely ignore. I feel like we can safely ignore the origin point. Right? Then similarly, if coordinates dot length would equal 1 because of this, we would return true. We might not know actually though. Well, yeah, if there's only 2 points and they must lie on the same line because there's only one slope that can exist. This still doesn't seem to work. Not saving the filtering at all. Not following what the issue is here. Undefined is not iterable. I think our conditional makes no sense. I think this makes more sense. Now that I'm thinking about it, we end up with the same thing with infinity, and that seems to be okay. It seems the issue seems to be with calculating b. How are we getting not a number? Something's off here. It looks like temp M and M are the same. Temp M and M are the same. Temp M and M are the same. And then B and temp B are the same, but we're returning false. What if we do, let me test something. If we were to do infinity minus 100, do we get not a number or do we get infinity? We get infinity. So well, what if we do, it shouldn't change based on the operations, but what if we multiply it by 100? We still get infinity, so it's unclear as to why this is an issue. What if we just print these coordinates and see what we get? Yeah, I have no idea what's happening here. For some reason, for some reason, I have no idea how I'm getting. So x1, which is 0 times infinity. So it looks like 0 times infinity gives you not a number. Okay, good to know. Then it seems like the solution So instead of using temp m, we're just going to use tm from now on. And we'll have say if am is equal to infinity or am is equal to negative infinity, we'll set it equal to 0, otherwise we'll get the value of am. I think we can just. I think we just have an edge case here. I'm trying to change the general algorithm for it. I think we should just code the edge case. The edge case is that if it's a straight line, then it's definitely a straight line, right? One way we can know if it's a straight line is just by checking the cardinality of x or y. So we can spread. You can do coordinates.map, right? C and only get the x coordinate, right? Then we can spread the whole thing, create a set out of it, spread the whole thing into an array, then we'll spread that into a set. We'll take the size of the set. We can do the same thing for both x and y, and we'll say if x cardinality is equal to 1, or y cardinality is equal to 1, then return true. Let's see. Yeah, I think we got lost in the sauce there. I think all we needed to do was handle the edge case. So we have check if n and its double exist. Given an array R of integers, check if there exist two indices I and j such that I does not equal j. The indices are different. I comes before j, and R sub I is equal to 2 times R sub j. I must come before j. There's no answer where that's true here. They're saying for I equals 0 and j equals 2. I equals 0 and j equals 2. 0, 1, 2. Where I does come before j. Oh, and R sub I is equal to 2 times R sub j. Okay, so it's just reversed. So we can do this in n squared time. I think we can do it faster too, but we'll say I is equal to R dot length minus 1. I must be greater than or equal to 0. I minus minus. Copy this and then we'll say j. Actually, j is going to be, when we do first, the outer loop is going to be j and the inner loop is actually going to be I. So I is going to be equal to j, right? I is greater than or equal to 0. I minus minus. And we'll just say if always make it less than. We'll say 1. If I is greater than or equal to 0, right? And I does not equal j, and R sub j times 2 equals R sub I will return true. Otherwise, we'll return false. I must come before j. I feel like this problem is all over the place. Okay, maybe I does not have to come before j. They're just saying that I or j. I see. It looks like this comma here doesn't mean that I is before j. It's just that they must be greater than or equal to 0 and less than r dot length. I'm pretty sure you could do this in linear time. If you loaded the whole thing into a set, each time you add an item to the set, I think this should still work too. So it looks like we could do a thing instead of using a set, we could use a map. That way we could make sure that they're actually different. But in almost every case, they're always going to be different. It's just that 0 is a little strange. But we can actually, instead of rewriting it, we can just make a little hot fix. Say if num equals 0, say zeros plus equal 1. And then we can say if, right, set dot has the number times 2, right, then return true. Additionally, we can say if set dot has if num equals 0 and zeros is greater than 2 greater than or equal to 2, return true. I was still wrong. Oh, right. We have to make sure that we have to make sure that num does not equal 0. Num does not equal 0, and we should be good. And then I think that's where we'll stop for today.